Anyone who has spent time studying Cold War bunkers, fallout shelters, underground storage depots, or early NATO listening stations knows that wood shows up in more places than most people expect. Timber was used for equipment racks, utility vault bracing, subterranean door frames, conduit supports, ventilation chambers, and even emergency framing. And in the damp, oxygen-poor, mold-thriving environments of these structures, untreated wood simply didn't survive. Engineers needed a method that wasn't just a surface coating, but a deep preservative infusion, something that didn't wash off, didn't flake, and didn't rely on exterior humidity levels to function. What emerged in the mid-20th century was a chemical wash so effective that many Cold War-era timbers are still fully intact today. This wasn't a mystery formula or classified cocktail. It was a combination of borat penetration, oil-based preservatives and solvent carriers that allowed the treatment to sink deep into the cellulose. For the next few minutes, we're going to explore exactly how this system worked, why it mattered, and how the underlying principles can be applied even today for long-term wood preservation. Cold War engineers relied on borat because it penetrated the wood instead of sitting on the surface. Borats had been known since the 1800s, but during the Cold War, their use surged because of how they performed underground. Borate salts dissolve in water and move through the natural pathways within wood, the capillaries and fibres, reaching areas that oils and tars could never touch. Instead of creating a surface shield, borates create an internal chemical environment that fungi and insects simply cannot tolerate. The Cold War advantage was that borats were non-volatile, non-corrosive and long-lasting, as long as the treated wood wasn't constantly exposed to running water. For subterranean structures, this was ideal. The timber stayed dry enough to retain the chemical, and the borat protected the interior of the wood for decades. A practical example from that time is the treatment of communication rack timbers in NORAD auxiliary sites. Maintenance logs show borat-soaked lumber lasting well over 50 years with no fungal penetration, even where humidity averaged 85%. If someone wanted to replicate this principle today, they could dissolve borax and boric acid in hot water, brush it onto raw, unfinished wood, and allow it to dry fully. The mixture wicks into the grain and stays there, providing long-term protection as long as the wood isn't placed directly in running water or exposed constantly to heavy rain. The Cold War method didn't stop with borat. After the salts fully penetrated and dried, engineers followed with an oil-based preservative that locked moisture out. This wasn't decorative varnish. It was a heavy, penetrating oil, often linseed-based or petroleum-derived, loaded with preservatives that hardened inside the pores. One advantage of oil is that it displaces water and fills voids in the fibres. Another is that it slows the movement of the borat toward the surface, preventing it from leaching out. In practice, crews would apply the oil treatment with wide brushes or sprayers, working it into every exposed surface. In outdoor Cold War installations, such as weather stations in Greenland or Alaskan radar outposts, this two-step combination meant wood remained stable even in freeze-thaw cycles that would normally split beams apart. A modern application of this approach could be using a natural oil, such as raw linseed or tung oil, after a borat wash has dried. It doesn't replicate every characteristic of Cold War formulations, but it mirrors the core function, internal protection, paired with a hardened moisture barrier. The secret weapon in the Cold War rot-stopping method wasn't the borat or the oil alone. It was the solvent system used to carry the protective chemicals deep into the wood. Solvents like mineral spirits or light distillates dissolved the preservative compounds and reduced their viscosity. When applied, the solvent would pull the mixture through the wood's capillaries before evaporating, leaving the active ingredients locked inside. This was not a surface stain. This was a full fibre saturation strategy designed for places where maintenance crews might never have access again. A clear example of this can be seen in declassified construction reports from several early warning stations, where solvent-carried treatments were used on structural timbers inside unventilated crawl spaces. Decades later, when the facilities were inspected or dismantled, many of these beams showed almost no fungal activity despite dark, damp conditions. Today, a similar effect can be achieved using commercially available oil-based wood preservatives that already incorporate solvent carriers. The key is applying them to raw wood rather than finished lumber, so the fibres can absorb the treatment deeply. When borates stabilise the interior of the wood, oils harden the cell walls and solvents carry everything into the deepest layers, the result is material with drastically altered properties. Cold War engineers described treated timbers as dimensionally reliable, meaning they resisted swelling, shrinking, cracking and warping far better than untreated wood. For underground military facilities, that reliability meant doors didn't jam, racks didn't collapse, and bracing members didn't rot in hidden corners. The principle is simple but powerful. Penetrate first, seal second, lock third. Anyone restoring old buildings, building off-grid cabins, or working with outdoor woodworking can use the same logic. Borat washes go on first. Oil-based treatments follow after drying. Solvent-carried preservatives finish the job by sealing the entire system together. This treatment remains one of the most effective wood preservation strategies ever documented. The Cold War was full of improvised problem-solving, but in this case the engineers left behind a method that still outperforms many modern coatings. It required no exotic ingredients, only a precise sequence and understanding of how wood behaves in hostile environments. Whether someone is trying to preserve a shed post, reinforce framing in a damp basement, or protect homestead structures that won't be accessible later, the underlying principles remain as relevant now as they were beneath Cold War soil. If you enjoyed this deep dive into forgotten engineering and want more historically grounded preservation knowledge, make sure to subscribe to Relic Logic and share this video with others who appreciate real, hard-earned history.